Hey Google, turn on the fan.
Sure, turning the patio fan on.
We're here today, guys, to see how that worked. I have a fan here that normally just has a remote control, and I managed to automate it. So let's go have a look. So this is the original RF remote for the fan. As you can see, you can turn it off, set speed, set timers and all that sort of stuff. I spoke to the manufacturer, Martech. They couldn't let me have any smart device. They didn't have a second remote. So I got a little creative and I found these cloning remotes online. So you hold one of the buttons while you press the button on the other remote and it copies the code. And that seemed to work fine. So I was able to have a second remote. And then the final step is I had some spare parts from another project and decided to link up a remote using relays. So that little board there is what you find inside that cloning remote. As you can see, I've just sort of soldered on some wires to activate the switches through the relays. And that's all powered by 12 volts through that barrel plug there. So the relay device there, an Arduino compatible one, uses 12 volts for its relay activation. I've got a spare little NodeMCU there, it's also taking 12 volts, and the cloning remote is 12 volts too. So it was all neatly the same power supply, just all through that little plug there. And then I've done the software with ESPHome and Home Assistant. So we'll show that in a minute, and that links through to my Google. So basically that's how I can talk to the fan. It goes through Home Assistant and then activates what's in this box here. So I've got this box stashed somewhere near that fan, so the little remote control device can communicate with the fan and tell it to turn on, off, and set at different speeds. Oh, I was going to mention about this relay board as well. It's pretty neat. So as you can see, these black wires there is 12 volt power that powers the relays. Obviously, to physically move the relay switching gear, it needs 12 volts. And then these colorful wires here are just the GPIO outputs from my NodeMCU. It's active high logic, so the 3.3 volts coming out on those GPIO pins is enough to tell us switches to trigger. So the relay switches trigger and activate the various buttons by means of these wires that I've got there. So what does this look like in Home Assistant? So you can see I've got the fan here, single fan. I can turn it on and off with the toggle, or I can go into my patio fan and adjust the speed this way. I don't have oscillation or any other settings available because my fan doesn't support them. It's just a ceiling fan. So how does that work? Well, let's start with ESPHome. So I've used ESPHome to program the NodeMCU device that's controlling the fan. I'll put this code on, but you can see here, basically I've got 4 relays. I've set them up as momentary switches. So when I turn the fan to high, it turns on the relay, adjusts the high. Same for medium, same for low, same for off. And those relays are literally just doing whatever the switches on that remote control were doing. So I've just mapped those 4 switches. The other switches I'm not bothered about. So that all goes through ESPHome, which presents Home Assistant with 4 switches. You can see them here. Fan high, low, medium and off. Now those are a bit ugly to have in the user interface, as well as being a bit tough to work with your Google Home and things. So what I did is choose to wrap those 4 switches up as a template fan. So Home Assistant has a template fan, which is a way of building your own fan device from some other lower level components. To do that, first I had to make some scripts to set the different fan high, medium, low and off. And then I had to, in each script, not only toggle, remember it's a momentary switch, so I'm doing the turn on for fan high, which does the momentary action through ESPHome. And then I have to set an input boolean. This is like a variable to store the fan state. The reason I have a variable is that I can't detect the fan state. It's just a simple remote control that sends commands to the fan. So I can remember the last command I sent and use that to assume that the state of the fan is that. So that's what I'm doing here. So I've got an input boolean, as well as actually an input select that stores the speed. So I'm remembering the fan on-off state and I'm remembering the speed state through these input booleans and input selects. Those normally come up in Lovelace unless you customize the UI, or you can hide them, which is what I've done. Finally, in my configuration YAML file, I've got the fan set up here. As I said, it's a template fan. That's what the platform template means. I've got my 2 input variables, input boolean and input select, configured there. And then down here, I've set up my template fan, given it a name. The value template is where I'm getting the state from, which is using this command here to pull the state. from that variable. Same with the speed template. When I turn it off, I run that script to set it high. That's my default on setting, sorry. And when I turn it off, I have the fan off script. And then when you set the speed, it basically interprets the speed value and passes that in using this data template thing. So it'll call the correct script according to what speed has been selected. And as mentioned, those scripts not only action the correct remote command to the fan, but also update these two variables so that the user interface state is correct in Home Assistant. Just to see that we're working, I can go back here. I can turn my fan on here, and go to my fan, adjust the speed. You may have heard the beep, I'm not sure. And then turn it back off again. And as you can see, everything works correctly.